Yes, I guess we are live, guys. Can you hear me? Yes, we are live. So, hello, guys. Before we start off, I want all of you guys to keep your distance, maintain social distancing, stay at home, and stay safe. I know these are difficult times for everyone, but then this is where we have to stay at home and study well. Okay. So, to study at home, crack IIT-JEE with India's largest platform, which is Unacademy, undoubtedly. Get the Plus subscription to access unlimited benefits. All right. So, this is how the learning app looks. You have to install this right away. It's a pretty cool app. We have regular quizzes happening there also. Okay. So, install it right away. What are you waiting for? So, hola amigos, I'm N Srikant. I did my BTech from IIT Kharagpur with an AR of 385. I've been guiding young minds like you guys for the last 4 odd years. You guys call me human calculator. Hello Adya, how are you? Yes, I'm a Sunrisers fan and DC is equally marvelous, if not better. So this is the program I'm launching for you guys. It's Ad Astra. It's aim for the stars and crack ITG. So Ad Astra means aiming for the stars. So I want you guys to keep your mind open to everything and then crack JE along with that. Cracking JE is a process. It's not like bas pad liya to ho gaya. You have to understand the bigger picture. Only then you can crack JE right away. That's my view of it. So that's it. So today we will be discussing about electric potential, potential of a dipole. We discussed about gravitational potential yesterday, electric potential. Yes, I am good, Adya. Thank you. I hope everyone's cool. So we discussed about potential yesterday. Today we will be continuing with that. We will finish most of it and how charges distribution happens. Okay, before we go, we'll just look into what we discussed yesterday. We discussed about some properties of potential, right? So we will continue with that once. Potential difference between 2 points in an electric field is defined as a work done in displacing unit positive charge from one point to another. Basically, it is worked. There's electric field, no? The electric field will push the will do some work. Electric field will do some work to take the body from A to B. Okay, we know electric field is conservative, so this can be potential energy can be defined. And what is potential energy? It is negative of the work done by conservative force, right? Change in potential energy. So this is what happens here. It is negative of the work done by conservative force, which is nothing but work done by external force. This in the condition that the body will not change velocity. This is generally assumed to be the case. If they give that velocity is changing, we have to start using work energy theorem there. We will look into a few problems on that also today. Okay. When the velocity changes, what happens? How does it affect and all? So that is, we'll do those problems now. And generally work done, so potential energy change is negative of the work done by the force, conservative force, which is also equal to the work done by other forces. So if you know how to do work done, you can find out potential energy very easily. Okay. Just like gravitational, it's also here. A unit positive charge is displaced from point A to B. Work done VB minus VA is minus. Exactly, no? Just like work done is force, you divide by charge both cases. Potential is work by charge. Same way, electric field is force by charge. Just do the same thing here, same calculation, we'll get this. Understood? No, it's the same thing. Potential or work, the potential energy, they both are same, only that you have a multiplication of charge. There's a q charge which is being multiplied. So that is where you have to be little careful, because if the charge is negative, everything will become flipped like negative mass. Negative charge, you can imagine it like negative mass. That is how. All right. So that is it. If a charge q is shifted from points A to B, work done against it is q into VB minus VA, which is what we discussed already. So this is how we come up to a conclusion. So what we say is electric field will always move from higher potential to lower potential. Because if it's going this way, work done by the field will be positive, no? Which means potential energy change is negative of EDR and potential energy change is negative of Q. This thing. So if you observe, E is along the same direction. If the displacement is also along this direction, this part will be positive, right? V delta V is equal to minus integration of EDR. This is how it is. Or minus integration of E dx. It's the same thing. Here, yeah, dx, they're all vectors. So if this is positive, this will be negative, right? Which means when direction of displacement is along the direction of field, the potential will decrease. That is why you say electric field is flowing from higher potential to lower. The same thing vice versa. Clear? Yes, very good. We will discuss about different how to link potential with electric field. Okay. One thing you have to understand that potential change is only integration of E dot dr dx from infinity to that point. Okay, so we define potential at a point as negative of work done to bring it from infinity to that point, because at infinity we are taking it to be zero. All right, so this is how we solve it. Remember one thing, while you're calculating potential for any kind of surfaces, any kind of shells or conducting spheres, non-conducting spheres, wires, anything, metal plates, potential energy will be negative, potential will be negative of the integration of E dot dx from infinity to the point. So you have to start at infinity. Your starting point should always be infinity, and you have to come to R. Getting it? So this is the main thing, guys. This is very important in understanding how to calculate a potential. If you understand this, then you'll always keep adding from infinity, because V at infinity is taken to be. That's it. So now we'll just use the logic. We know for a charged shell or a charged sphere, shell or charged conducting sphere. Either ways, because in a conducting sphere will behave like a shell only, that there is only outer layer of charge. There is only one layer of charge on the outside. Understood? So this is the one important thing. So now you just take it from infinity till the point it reaches the surface. What will the field be? Field will be q by 4 pi epsilon r square, which is given here. Surface field will be E by 4 pi epsilon naught r square, which is clearly given here. So, and what will potential be? The field will be outwards and the point is coming this way. So logically I'm telling, the field is always outwards, right, from a positive charge, and the point is coming from infinity towards the point, towards this surface, which means potential E and dr are having opposite directions. So potential will be positive. Getting it? This is the logic I want you guys to understand. Direction of movement, E vector. So potential final will be greater than potential initial, which is zero. Getting it? Are you able to understand this way? So logically also you can think about these things that way. So of just formula approach. You can also imagine it like field is going in the right direction, dx is in the opposite direction, which means E dot dx will be negative. And integrate negative of integration of that negative of negative value is positive, which means so that way you can remember of this formula now. The field potential will be how much? Directly I won't even integrate here. I will just write q by 4 pi epsilon naught r, because I know integration of 4 pi r square will end up getting r only. And you also remember a little of formula. It's not like full formula by hearting, but this is the analytical way of remembering it. All right. So we got it till here. Now from r to inside, this is where you have to be very careful, guys, especially kind of problems. From r to inside, everywhere what is field? Field is zero. Inside a shell or inside a metal sphere, conducting sphere, the field will be zero, which means delta v will be zero, and we can say v inside will be equal to v on the surface, because once you go till the surface it reaches, the potential will keep increasing, because more and more displacement is happening, more and more field is also opposing. So both of them, as it comes closer and closer, this will become more and more negative, and potential will give more and more positive. Understood, right? Yeah, it's okay. Sim24, nice logics are happening today. Just we'll relax and solve some problems, solve some situations. So you're getting it now. Field is in the opposite direction of displacement, then potential will keep increasing. So over V inside will be equal to V on the surface, which is equal to Q by 4 pi epsilon naught R. All right. So this is the graph how it looks. It is increasing, the field is increasing like this. So this will have a little different slope, because this is 1 by r function and this is 1 by r square function, k by r and k by r square, some constant. So this function will be little less steeper than this graph, very fast, because r square will happen faster. So curves are little different, but you can say the entire thing will look approximately like this. So how we draw it. All right. So now is the most important thing. It is potential due to a non-conducting sphere. What will happen when you have a non-conducting sphere? So one thing we know, outside is the same as conducting sphere. It behave like a point particle. Field will be E by Q by 4 pi epsilon r square, and this will also be the same. We can directly say till the surface V is equal to Q by 4 pi epsilon naught. We'll call it small r because till r is greater than or equal to r. Till the surface, we can use this formula, right? Once we go inside the surface, we know how field is changing. We know field is changing. What is the field inside? Let me draw a sphere. We have sphere here. Okay. At a distance r, if I take a small element here, let's just take dr element here. All right. You know the field at this particular point, right? If you don't remember the formula, you can derive it also. You can derive it like uh, the entire charge is plus q on the sphere, which means inside the sphere there is volumetric distribution. I'm telling this once again because I hope you don't forget it. This is very important. Once you understand this kind of things, it becomes very easy to continue. Like you can remember, you need not remember formulas. You can understand formulas. Okay. So volumetric distribution is happening here, which means there is density of rho. Sigma is for areal. No? So we can directly write field will be equal to K into Q inside wait, field KQ inside by R square. We can write off this directly. This is the general formula. Every shell which is inside, every charge which is inside in a spherical conduction, you can take the entire thing as point, just like in gravity. Understand? Every charge inside behaves like point charge. That is the main emphasis we are going to discuss. Okay, okay. I'm going to tell you. So everything which is inside is a point charge because everything spherical is very symmetric Gaussian surface. So that is the main concept here. So we can use this, and directly we will get k by r square into q inside will be proportional to q inside will be proportional to q is generally proportional to volume. No, q is proportional to volume. I'll explain this. This is also a nice way of improving logic. Okay, this is a very nice technique about q inside. I'll discuss about q inside. Charge inside के लिए I will give you a very nice logic. Charge inside is nothing but density into volume. No, density into volume. Whatever volume is inside that entire thing, this entire volume will only give the charge inside. So we can directly say this is nothing but rho into 4 by 3 pi r cube, pi r cube, whatever r is there. This r, yes, r, right? Q inside will be rho into 4 by 3 pi r cube. So directly we can write off q inside will be proportional to r cube. So from this, by unitary method, we can say q inside by q total will be equal to r cube by capital R cube. Why? Because q total will be proportional to total radius. No, divide both of them. When both are proportional by same constant, you divide both of them, you can equate them. So this is one very nice technique to remember or even solve it. Okay. So let's continue with this. So let's get back to this. So now inside a sphere, I will just solve it using that logic. I can just derive it using that logic. But in distance r, if I take dr, I will say field will be equal to k into q inside, which is total q into r cube by r cube, which we just got from the ratio we got it. No, so q inside by q total will be equal to r cube by r cube. From this we will get q inside is equal to r cube by r cube, capital R cube into total cube. So this is how we hello Srinivas Reddy. So this is the method, you got it right. So I'll just put it here by r square. So from this I'll get E is equal to k cube by r cube into r. Okay, so this is how it works. Getting it. So now we found out field. You can remember this formula, or we will just use this here. So what is potential at a particular distance? It is nothing but V infinity to VR plus VR to VR. So what I'm saying is from infinity to this point you have a potential. This point has a potential R on the surface. From there, the further you go inside, so this is VR minus VR minus wait. So you're understanding that here whatever potential is there, V at R will be equal to VR plus minus integration of E dot dx, dr in this case. Getting it from R to small r. So you're starting from outside and coming inside. Are you getting it? You're starting from outside and you are coming inside. Starting from outside and coming inside, your outer limit will be R, lower limit, and the upper limit will be smaller. So this is what we'll directly apply. We know the value of this is k q by 4 pi epsilon naught r, so the capital R, plus minus integration of k q by r cube into r e r from r to r, capital to small. So this is the formula, guys. Once we start integrating, you know, k cube by r cube into this r square will be r square by 2. We will get this. Integration from r to r will give us k cube by r cube into r square by 2 minus, right, the whole thing will have minus in the end, along with k cube by epsilon. So just add the whole thing. Minus 1 minus will become plus here, and this will have a negative impact. इससे क्या हो जाएगा? K cube by r cube. So using both of them, we'll end up getting formula like this: k cube by r cube. Take this whole thing common. I'll make this r cube into r square. So we'll get r square plus r square by 2 minus r small. So this is how the formula will look. So eventually we will get potential at a distance r will be k cube by 2r square into 3r square minus. This is how we'll get the value to be. So this is the one. This is the solution. It's very straightforward if you observe. Just we found out the field without remembering the formula, and then we started gradually integrating across the whole thing. You have to have clarity of thought that the sphere volumetric distribution. So you have to understand that the particle comes from infinity towards this point. So you have to start from infinity and come slowly lower. From infinity to r, we know the potential is VR. We already found it out just now. And from R, you have to go inside, getting it. So the outer limit should be, the lower limit should be capital R, and the upper limit should be smaller. That is where you are reaching finally. Getting it? So that is the main concept here. Next, we look into the graphical analysis. It's pretty simple. So here we get V is 1 by 4, Q by 4 pi epsilon naught r, which we discussed. So the entire time it will behave like a point particle. I'll directly use the formula for point particle. This is easily derivable, rememberable, everything. And from here to here, we got this formula. V is Vs, which is what we actually found out. So 3 by 2 r square, Vs by 2 into 3 minus r square. So this is what he got it. It's the same formula. So what did we get here? Kq by 2r square into 3r square minus r square. So this is nothing but Kq by 2 r cube. Sorry. Kq by 2r into 3 minus r square by r square. It's the same thing, no? Anyway, both of them are writing in the same way. So we can use this. Yeah, r cube in the denominator. Yes, exactly. Good one. So this graph will look like this. It is a downward parabola. If you observe this, this is a downward parabola because it is some k minus bx square type formula. K minus bx square. This is a and this is b. Getting at minus 1 by 2 minus vs by 2 into r square by r square is b. So that way, if you remember it, this is a downward going parabola. So the graph will have a downward parabola first, and this is a 1 by r function. This is parabola, and this is an 1 by r function. So this is the subtle difference there. Yes. Oh, in this one. So yes, this is the solution, guys. Great job. Now today we will discuss about what energy stored in a dipole. Okay, this is what I want you to understand from the core. Like It's very simple. There is one single formula for this. We'll derive it without any integration. I'm trying to make this as much integration free as possible so that everyone who's preparing can understand. All right. So it's pretty simple. One thing is, if both charges were the same place, so we have to find out the potential energy stored in a dipole. Suppose dipole is nothing but one positive charge and one negative charge separated by distance d, and then we'll get the dipole moment to be the moment of dipole is equal to q into d. The direction of d vector is from negative to positive. That is all little. So if there's negative charge here, positive charge here, direction will be in this direction. The direction. That is how we remember it. No, potential unit dipole is dipole moment is equal to q into d. This is one thing we remember. All right. Now, suppose if both the charges were at the same place, they're coming from infinity. Both of them initially, both of them have negative potential, zero potential. They're coming slowly. If they come to the same place like this in electric field, if they come to same level, or just let's say just same place only. Let's take this is a negative charge. Negative and positive are together. Now the negative charge came off here. That's all. There's nothing else. You're getting it, guys? So the positive charge which was there will be there. The only difference is negative charge is a little distance away. How much distance is it? D distance away. Understood? So here negative charge wants to go in this direction. See, the negative charge is going opposite to the direction of field, which means here work done by field will be positive, which means potential will be negative, because logically if you observe, negative charge will like to go to the left only. Getting it? Negative charge would like to go to the left only in this given question. So if it is going along left, it means its potential energy is decreasing, or even potential is decreasing. Getting it? So potential due to a dipole by logic in stable state is negative. And how much is the value? It is nothing but work done by the negative of work done by the field by charge. That is minus E into D, minus E into dr. Right? Potential energy, no? Potential energy is minus F into dr. That's it. Conservative force. Now, what is the force on this charge? It is this way. It will be negative charge. No, this is minus Q. So the force will be minus QE. So we can directly write minus QE into dr. Dr is how much distance is it traveling from 0 to d distance. So directly we will get potential to be minus QE into d. So potential of a dipole in its stable position is minus QED. Getting it? The potential of a dipole in its stable case is minus QED from natural solving. Okay. Hello, Amma. Hello, Sairam Garu. So this is the first concept you have to understand. And at an angle theta, let's take another condition where it is making an angle theta with the field. The dipole is like this and field is like this. Now what will the separation be? This length will be d cos theta. This will also be d cos theta. D by 2 cos theta, d by 2 cos theta. So the total length will be, this is theta. So this will be d cos theta. No? So directly we can write u of a dipole at angle theta will be minus PE cos theta. That's it. Over. This QED is nothing but minus minus QD is equal to P, right? From this, we can directly write minus PE. Even better. Got it? So potential due to a dipole will be equal to minus PE cos theta. Understood? So this one I want you guys to note it down. This is a very simple formula and the derivation is also very simple. There is nothing here. So note this down. Yes. So we understood the potential due to a dipole is minus PE cos theta. Okay. Now, potential energy stored in a dipole. Like, how do you define potential energy stored in a dipole? We took initial potential. Initially, at this case, potential is minus P, right? Because angle is 0. Both are along the same direction. At this point, is the potential is minus P cos 90, which is equal to 0. And here, potential energy is minus P cos 180. Wow. which is equal to dull today. Nothing, man. I just changed the place. I think this lighting is a little problematic here. I'm shifting houses, though we have. I think it's a little issue with the light and this room. Hello, Ramesh. How are you? So you're getting this concept? No, whatever, man. Okay. I just had a bath and came through. All right. So potential energy is minus PE here. It is okay. Let's try to amp it up then. Potential energy here is how much? Minus P. No, we just discussed. And at 90 degrees, it will be minus P cos 90, which is 0. Here it is plus, here it is PE. So here, work done will be minimum by the external agent. If you want to bring it from here to here, what is the work done by external agent? It is change in potential energy, right? So how much is change in potential energy? 0 minus minus P, which is equal to P. So what is the work done here? It is P. Understood? And even torque in this specific case will be equal to P. If you observe here, the positive charge force will be this much, here it will be this much, so it will directly be P, torque also. And in this particular case, it is moving from this end to full ulta end. No. So directly here we will get initial work external will be external work will be change in potential energy. Always remember this point. External work done will be equal to change in potential energy. When you are lifting a block up, potential energy is increasing and you are doing positive work. That way, if you just imagine lifting a block, everything will become clear. Okay. Just work done by external agent is change in potential energy. Over. And now from here to here, potential energy, what is work external now? Final potential is plus P, initial potential is minus P. So total work done will be 2P. Getting it? Yes, so note this point also. It's a very basic understanding of it with which you can solve any other problem. Anything you can solve this. Hello Saket, hello Ramesh. How are you guys? So note this point down. Now let's go to a potential energy in a dipole charge system. We're just making some examples. This is kind of an example. Potential energy in a dipole charge system. What is this? There is a charge q here and the dipole which is moving along this particular direction, which means this is the negative charge, this is the. So what is the potential energy of this dipole system? We have to find out. Okay. So one more thing, again, I will tell you just by logic. I won't even tell the value. I don't know how much the value is, but just by logic, I can say if the dipole is in this direction, negative charge is here, positive charge is here, which means negative. If these both were together, potential is zero, but negative charge came closer to the field. If you observe, the field will be in this direction, and the negative charge went this way, which means the work done by the field will be positive. No, negative charge, which is more attracting, came off closer. Just like a thread is falling from top, at the top, if you leave a thread with a ball, there it will be staying like that. And suddenly, if the ball falls, what will happen? The potential energy is reducing. Same way here, charges initial. Now this negative charge went back like this. Negative charge got attracted to the field, which means here work done by the field will be positive. And by seeing this only, we have to understand that potential will be negative. Just by looking at this. समझ में आया? So once you get this positive negative, everything will come little more easier because you know if it is positive or negative, potential is decreasing or increasing, potential is increasing or decreasing. Same thing you can get off. Understood? So this is one thing, and now we'll just solve another way. So what is the potential energy? What is the this thing we discussed? Field potential energy will be equal to minus PE cos theta. That's all. This formula directly we apply also, we'll get the answer. Okay. So at this particular system, what is the direction of P? P direction of a dipole is this, and direction of field is this. Same angles. So directly we'll get field is equal to minus PE. And what is the value of PE here? Minus of PE into the field at this point. What is the field at this point at a distance A due to a point charge? Field will be kq by r square. Okay, so we'll directly write off this minus P into kq by r square. So minus kpq pqr square. That's it. हो गया. Either use direct formula or use the logic of whenever you have any confusion, imagine it like potential work done and all. If you are imagining it this way, it automatically will help you get the right answer. You will not get confused with negative charge, positive charge, work, and all those things. Okay. So yes, pretty cool. Next, calculate the force on a dipole in the surroundings of a long charged wire as shown in the figure. There's a long charged wire here. What is the field on a dipole like this? It's also very straightforward. I'm just dipole charge system, just making some examples of dipole. So this is a great question. Lambda is the charge here. So same logic again. The field will be outside. Again, the potential will here be negative. Getting it? The potential here will again be negative. Potential will be negative. Potential energy also will be negative. We understood this just the same logic as before. Okay. And now we'll directly use the formula. What is the field due to an infinite charge? It is lambda by 2 pi epsilon naught r, or you can also call it as 2k lambda by r square, r, yes. So this is the general formula we can remember. This is very simple to remember also. So or else you can use Gaussian surface and solve as we discussed. So here the field is this much, and now just by simple logic we can get off the value. What is the value? No, minus p into e, because p field is in this direction and even p is in that direction. So we'll directly write potential energy is minus, which is minus p into 2k lambda by r square over r. That's it. Simple, no? All these problems, any dipole question also, you can solve it very peacefully. And you have to understand how this dipole system, with which we have to understand the broader understanding. Ki negative charges are moving closer to the field, matlab the potential will be negative. If the positive charge is moving towards the field, it means that the external, someone is only pushing it that way, which means external work done will be positive. So potential will be positive. Getting it? So this way anything you can solve. And so let's talk a little about Unacademy. Crack IIT-JEE with India's largest platform, which is Unacademy. Get the plus subscription right away. Get the plus subscription right away and access unlimited live and recorded courses from India's best educators from everywhere. Okay. So what do you get in plus subscription? You get daily live classes like we are having here. You have daily live classes there. You can chat with your educators. Like there will be live chat there, which is pretty awesome. You have to install the app. I'm telling you, everyone, it's pretty cool. Engage in discussions. Ask your doubts. You can have nice discussions with them. I enjoy it a lot, especially there. The discussions are very dynamic. Here there's a little delay, but there it is very dynamic and it's awesome. Answer polls all where the class is going on. I have quiz program which is running. It's called the daily quiz show. So do stay tuned there. I'll have it twice in every 3 days. Today we don't have it today, but tomorrow we're having one class. It's the eighth episode. So it's happening every day for the last 1 week, 2 weeks. So it's a very cool quiz. You have to come there to understand it. Okay. So install the app. Do that right away. You get live tests and quizzes every day. You get basically what I tell you about preparation for JEE is you have to prepare for the exam. So you have to write tests every day. Write tests regularly. All right. So Unacademy app, when you take the plus subscription, you get in a lot of live tests which you can continuously practice daily. You can write a test every day. Okay, that is a very important advantage here, guys. And you get structured course where the whole it's already done. The entire project is done so that you can have unlimited access to this data whenever you want. Like if you're having some work in the morning, or you have some you don't want you have you're a night person type of person. If you don't want to wake up early morning to college, you have recorded sessions. You have structured courses there where you can watch it at any time you want. All right, so get the subscription, guys. It's pretty cool. Use this code NSS1. The cost of it is generally 38,500 for 1 year, but if you use this code NSS1, you get an additional 10% off, which makes it 34,600. The cost of this is 2,888 rupees per month. If you look it in a shorter frame, this might look big, but if you look it in the shorter frame, it's 2,888 per month, which is 96 rupees per day, and 32 for physics, chemistry, and maths. 32 for physics, chemistry, and maths. Not only this, you get lot of Ache Fund from all the teachers. Lot more will be happening there. So just go for this, guys. Those who are cracking 2021, you can take this without any doubt. For 2 years, so cracking 2022, you can take this. You get use the code NSS1. You'll get it for 50,000, 23 rupees per day. So that's the main thing. And as Joker says, when you're good at something, don't do it for free. So that is the nominal fees, which is the cost of doing something great. And not only this, this is iconic subscription for students who have a lot of enthusiasm and less planning. Okay. Yes, a quiz a day prepares you for JEE any day. Yes, that is exactly correct, Sim24, which is what I believe. Personal coach will be given to you an iconic subscription, so he will help you. This is for those who need the help of a teacher. Okay. Use this, and you will get a teacher who will help you, guide you through your test analysis and through your study plans. He will help you through all these things. He'll make a plan. There'll be a plan given to you. There'll be detailed test analysis and all these, along with all the benefits of Plus. All right. So this is it. This cost is 50,400 for 12 months because you're getting an additional teacher. It costs you 46 rupees per day for physics, chemistry, and maths. So you can just go for it. And when you're going, use the code NSS1, which will give you extra 10% off. All right. So that is the awesome thing. So now let's just calculation and analytical problem. This is just a calculation and analytical problem. Like I told you, I want to do it in an analytical way. All right. So look at this problem. I'm giving you 2 minutes to solve it. Come on, guys. I'm going to give you 2 minutes. So don't have a timer here, but yes, I want you guys to solve this. Along with this, just so you have to understand this in vector form also, like in directions. If you can give field, like given in the graph, like y is equal to 3 plus x is the direction along which the field is there. And the particle, there are 2 points A and B. If you are able to visualize them separately, like in a graph, everything will become much easier for you to understand because you can solve in terms of angles. All right. Another way of solving it is by writing E field vector and writing dr vector. Yes, good one, Adya. Zero is the answer. Great one. She got it within 1 minute. Under 1 minute, half minute. That's great. So yes, that is exactly right. Did you use that logic or use the integration function? There are two ways. I'll solve it in both the ways. That is how, matlab, that is the best way of understanding it. You solve one problem in two, three ways. So that itself will cover a lot more problems than actually, matlab, 100 easy problems. करने से one thing I'll tell you. 100 easy problems are better. Hey, you do 10 tough problems. 100 easy problems, don't do them. 10 tough problems, do them in 2 3 different ways. Okay, that will help you a lot. This is just example, so I'm telling this, but otherwise take tough problems and make it solve it in different ways. That is the best way to go. So let's first I'll do it in the analytical way. I like to draw graphs and solve problems, so I'll generally solve it in graphical method. So field का direction y is equal to 3 plus x में है. तो 3 plus x का ग्राफ कैसा होगा? Slope is 45 degrees. Slope is 45 degrees with the horizontal. So this is the direction of field. The field will be in this direction. The value is 100 volt per meter. Now where is point 3 comma 1? 1 2 3 1 2, call it something like that. So 3 comma 1, first point is here, point A is here, point A is here, and point B is there. So this is the displacement vector, point A to B. So simple, if I know this angle, I can solve it, no? So by using it, this from here, what is this slope? This slope, this is reducing by 2, this is increasing by 2, which means this slope is 45 degrees. And if you observe, this slope is also 45 degrees. Hence, if you see the whole thing, this angle is 90 degrees. No, this angle is 90 degrees, which means angle between E and dr is 90 degrees. So directly you can say work done by potential is 0, which implies change in potential is what it is. This the method you use, Adya? If that is the method, it's pretty cool, no? Another ways you can find out E dot dr. E vector is 100 volt per meter into the direction will be unit vector. No, it's I cap plus j cap by root 2. ये root 2 क्यों है? To make it a unit vector. Got it? So this is the field vector, and dr vector is r final minus r initial. So use the whole thing, which is how much? ये 3 I cap plus J cap है, ये I cap plus 3 J cap है. So directly we'll get 2 J cap minus 2 I cap. तो दोनों को डॉट प्रोडक्ट कर दो. Minus integration of E dot dr, which is E dot dr only. In constant cases, this is E dot dr, E dot delta r, minus 100 by root 2 times I cap plus J cap dot 2 J cap minus 2 I cap. तो इसका I dot I minus 2 हो गया, J dot I plus 2 हो गया, so is minus 2 plus 2 is 0. Over. Understood? So there are two methods of solving. This is method 1, which is elegant. This is method 2, which is technical. The two ways of approaching. One is elegant, analytical. One is calculational. So that's why I wrote calculation and analytical. This is method 1. This is method 2. Pretty cool, right? So if you want more such things, just take the Unacademy app. I'm doing a lot of courses there, a lot of classes there. So install the app right away. Use the code NSS1. This is how you solve this. Simple methods. You either do change in potential is minus E dot dr, or you just analyze it in terms of angles. Yes, so pretty cool. Now we would, so one thing you have to understand here, when field is proportional to when field is perpendicular to the displacement vector, what do we understand here? That the potential difference, the potential difference here is zero. Change in potential is zero, which means these potentials are V is same. So such surfaces are called as equipotential surfaces. So what are they called? Equipotential surfaces, where the potential difference is zero. Those kind of things are called equipotential. So that is the next topic we'll be analyzing before we go to the next one. So it's just a flow. Equipotential surfaces for a given charge distribution, locus of all points having same potential is called equipotential. All points which have same charge, the same potential. Like I will give you an example. Like if you take a sphere, or like we just took till now, what was the potential k by kq by r was the potential, q by 4 pi epsilon naught r kq by r. So every point which is a distance r will have same value. So what is the potential surface there? It's a spherical. Every part in this entire sphere of radius r will have same potential, no? In that shell of radius r, every point is at r distance from the center. So directly that is their equipotential surface. So such kind of surfaces which have same potential are called equipotential surfaces. Got it? Okay. So equipotential surfaces can never cross each other because, of course, suppose you have two values. One is 17, one is 16. One surface is 17, one surface is 16. If they both cross, what is the point? What is the value here? It is not defined. No? Logically, if you have one line of 17, one line of 16. If both of them meet at a particular point, this point will not have any defined potential. It's having two things at once. So this is not possible, which means equipotential surfaces are always they never cross each other. Okay. Equipotential surfaces are always perpendicular to the direction of electric field, of course, because it is nothing but E dot dr. No, if E is perpendicular to dr, we just figured out that potential difference will be zero. Those kind of surfaces are only equipotential. So everything which is perpendicular to the field, that surface entire thing will be equipotential. So let's take some field like this. Something like this is there. So how will the surface look? It will be perpendicular to all the lines. This will be equipotential surface. Are you getting it? This is pretty cool. Now I'll draw the different colors because. So देख एक ऐसा एक surface है, ऐसा एक है. Then there is one more like this, and one more like this, one more like this. So how will the equipotential surface look? It will be perpendicular to this, perpendicular to this, then perpendicular to this, perpendicular to this, and perpendicular. How the surface potential. Getting it? So this is just pretty cool. So yes, if a charge is moved from one point to another point, so this is about these 2 points. You got it right. If it's perpendicular, then there will be no work done by electric field or by external agent. So that surfaces will be equipotential. Yes, if a charge is moved from one point to another over an equipotential surface, then the work done, which we just discussed, both have same potential, which means work done will all potential means potential energy also. So their work done will be zero. Just like in gravity, some plateau. If you have a plateau and a ball is rolling on a plane surface, is the gravitational potential energy changing? No. That is why that horizontal surface is equipotential. Everywhere the potential is mgh on. Same way here also it will be q into v. That's all. Understood? So this is something shapes of equipotential surfaces we will discuss now. And one more thing, the intensity of electric field along an equipotential surface is always zero. So it is always perpendicular. Field is always perpendicular to the surface, which means along that direction component will always be cos 90 degrees, which is zero. Understood? Pretty simple, right? So these are some. So note these points about equipotential surfaces. This is very important. You understand this, it will give you a good perspective. So okay. So you understand the main points. We already covered this. It's all just interpretation of what we already discussed. Equipotential surfaces are always perpendicular to the direction of electric field. They don't cross each other. When they have same potential, they are called equipotential surface. Work done to move along that direction will be zero, and the intensity of the electric field in that direction will be zero because they are perpendicular. Simple. Now these are some examples. इसका potential V1 है तो हमेशा या for uniform electric field, how do you think the perpendiculars will look? There is uniform electric field like this. So perpendicular will be this whole plane, no? Everything which is perpendicular to the field. So this angle will be 90 degrees. Everything. So this is how the equipotential surface will look. So this is very, so all these are similar to Gaussian surfaces basically. Equipotential surfaces are how you have to take Gaussian surfaces. Now this is the better way to explain it to you, that everywhere you have a Gaussian surface, no? That Gaussian surface should be equipotential, only then that Gauss law will just stick to you. Okay. Take equipotential surfaces, the entire place the field flux coming out will be uniform. So everywhere field will be same. That symmetry will be there. Getting it? Symmetry is equipotential surfaces, like Gauss law. Okay. So now for a point charge, we just discussed for a point and a sphere. For point charge, spherical conductors, equipotential surfaces are spherical. We already discussed this in the previous slide. Okay, for a line distribution of equipotential charge, for line distribution or cylindrical distribution, the field will always be perpendicular. No, along this direction, the field will be exactly out. So this whole thing will be equipotential. Simple, right? Two objects connected by one more thing. Suppose there is one higher potential and one there is lower potential. Best way to explain a wire is like a road. There is a higher place. There's a higher place here, and then there's a lower place. The ball stuck here. Suppose I build a road like this, what will happen? This ball will start rolling down to the lower potential, right? Till both of them have same potential type situation. Getting it? The ball will start rolling. Similarly, when two wires are connected, two objects are connected by a wire, they will also make sure from higher potential charge will move to the lower potential, or electrons will move from lower to higher because electrons are negative mass. So either ways, if you understand, charge will move from higher to lower, positive charge, and eventually it will reach same potential on both sides. Getting it? So this is very important point here. Two objects connected by a wire also will have same potential. This is a very important topic. We'll do a few problems on this today. And before we go there, I want to also tell you about electric potential gradient. So this is the example. So note these diagrams down. This is very important for understanding equipotential. या पॉज करके रख लो, पॉज करके देख लो, ठीक है? विल कंटिन्यू आफ्टर दैट. नाउ फॉर द नेक्स्ट वन. पॉज किया, अनपॉज भी कर दो आप. चलो, इलेक्ट्रिक पोटेंशियल ग्रेडियंट. Now the rate of change of this is the reverse. We know V is minus integration of E dot dr ना. तो इसका उल्टा फंक्शन कर देंगे हम. dv is minus E dr basically. पहले ये है change in potential is this one. So we can also write dv is equal to minus E dot dr, right? So this is the general another understanding of it. तो इसको अगर तुम रिवर्स ग्रेडियंट कर दी, इफ यू डू द ऑपोजिट ऑफ इंटीग्रेशन प्रोसेस हियर, वी कैन डायरेक्टली गेट दैट द फील्ड विल बी इक्वल टू, उसका एकदम dv by dr आ जाएगा। तो लेकिन dv इज अ स्केलर, तो उसको तुम कैसे करोगे? यू हैव टू पार्शियली डिफरेंशिएट इट। ये कुछ बड़ी बात नहीं है, मैं तुझे बता दूंगा पार्शियल डिफरेंशिएशन मतलब क्या होता है। आई टेल यू राइट नाउ, डोंट वरी। ओके, तो ये डो v बाई डो y टाइम्स जे कैप प्लस डो v बाई डो z टाइम्स ए कैप, सबका माइनस है, ठीक है। तो दिस इज द होल थिंग, दिस इज ओनली कॉल्ड ई इज माइनस डेल्टा v। ओके, दिस इज पार्शियल डिफरेंशिएशन। So potential is a scalar quantity, but gradient is a vector quantity. This is how you convert a scalar to a vector by partial differentiation. Partial differentiation means you take one as constant and everything, you take one as a variable and differentiate everything else as constant. Like मान लो e is a function of x, let's say it's x square y cube z square, कुछ function ले लिया v, v को कुछ ऐसे function कर दिया। This is how it looks. So then field will be how much? So what I'll tell is it's different partial differentiation of dou x, मतलब इसमें x को वेरिएबल कर दो और बाकी सबको कांस्टेंट ले लो। Getting it? So just give me one new page to explain. तो पार्शियल डिफरेंशिएशन थोड़ा इसमें देख लेते हैं, इसमें कुछ नहीं है, जस्ट सिंपल लॉजिक है इसमें, nothing much happening there. It is just differentiation. Let's take v as v is x square y cube z power 4 कुछ ले लो, ऐसे कुछ रैंडम फंक्शन ले लिया मैं। यू हैव अ बेटर क्वेश्चन एंड इजियर क्वेश्चन ऑन द आउटसाइड। ओके, तो ये एक फंक्शन ले लिया, तो डो v बाई डो x मतलब you take x as a variable and everything else is constant. This is partial differentiation where you're taking only partially, when there are three variables but you're only taking one of them to be actually variable, the others to be constant. Y cube and z power 4 are constant. तो इसमें कितना हो जाएगा? ये 2x हो गया, 2x into y cube z power 4, dou v by dou x is this much and dou v by dou y, इसमें बस y को डिफरेंशिएट करो, बाकी दोनों को रख दो, 2y square into x square z power 4, dou v by dou z इज इक्वल टू, बस z को डिफरेंशिएट करो, बाकी दोनों को कांस्टेंट लो, क्या हो गया 4z क्यूब इंटू एक्स स्क्वायर इंटू वाई क्यूब। बस हो गई बात, नो डाउट हियर। So this is the main difference. We know v is integration of e dr minus. So from this directly we will get e vector. If you want to get a vector from a scalar, partial differentiation is to get vector relation from scalar. Okay, so this is how it works. All right. You have to get a vector differentiation from a scalar. Like let me explain it in the best possible way. You know, all of you have studied little geography, थोड़ा इसमें मैं geography मुझे अच्छा लगता था, तो I little give an idea using geography. You know latitudes, longitudes ले लेते हैं, latitude नहीं, कुछ भी, latitudes and longitudes क्या है? ये numbers है ना, but numbers से तो you are able to understand कि it is going left or right. If you know that's zero latitude, it is at that what do you call, इंग्लैंड में एक प्लेस था, वहां पे था, और उसके बाद पॉजिटिव लैटिट्यूड्स आर गोइंग टू द राइट, नेगेटिव लैटिट्यूड्स आर गोइंग टू द लेफ्ट। लॉन्गिट्यूड आल्सो, लैटिट्यूड्स मतलब इक्वेटर था ना, हाँ सॉरी, लैटिट्यूड्स इक्वेटर वाज 0 and then you have 20 degrees, 23 degrees, our earth, our इंडिया स्टार्ट्स एट अराउंड 20 डिग्रीज। तो ये सब 20 डिग्रीज का नंबर क्या है? 20 डिग्रीज का नंबर मतलब है ये इक्वेटर से 20 डिग्रीज ऊपर था। ये जो कॉन्सेप्ट है यहाँ पे भी वही है। तो यू हैव टू गेट वेक्टर रिलेशन फ्रॉम ए स्केलर रिलेशन मींस, यस ग्रीनविच करेक्ट। तो वेक्टर रिलेशन फ्रॉम स्केलर मींस इसी टाइप का रिवर्स करना है, बस रिवर्स डिफरेंशिएशन, रिवर्स ऑफ इंटीग्रेशन। तो ये पार्शियल डिफरेंशिएशन से होगा। Getting it? This is the physical understanding of partial differentiation given by me. I don't this is my interpretation. Okay, all interpretations are subject to market risk. Read the full video carefully. Okay. So from this E vector, I'll get it as dou V by dou x I cap. मतलब x डायरेक्शन में पार्शियल डिफरेंशिएट करते हैं वो x कौन सा डायरेक्शन में x is in I cap direction. So I put I cap. Again, dou V by dou y is in j cap direction. So that is how I just solve. Got it? So this is how we get it. Now let's look at a small simple problem. I want you guys to answer this. Find the magnitude of electric field at a point x, y, z. I'm giving you 1 minute to this. Start now. Go for this. I want to find the magnitude of electric field. I also want to find the electric field, not just magnitude. But magnitude बता दो तुम लोग. ठीक है. काफी अच्छा आंसर आएगा इसमें. मैग्नीट्यूड कर दो. Right now. Hi Ravi Ravi. I'm good man. So guys, ये how are you? So one thing I want to tell you guys, share these videos everywhere because this kind of this I feel is my way of expressing physics to you guys. So I want you guys to understand this in a different angle so that your perspective might change a little, and all you need sometimes, like in situations like this, is a little push. So if little change in perspective happens, it will affect a lot in your way of preparing for JEE. So I want all of you guys to share it everywhere. All right. So yes, let's see what is the answer. The time is almost getting up. Yes, ये टाइम अप हो गया. कोई आंसर नहीं दिए, but it's all right. I'll solve this. तो इसमें simple है. We already discussed how to do it. So minus dou v by dou x is the x cap I cap field, which is how much? Minus 5. So first we'll find out dou v by dou x minus 4. Okay, dou v by dou x minus 5 because x this whole thing will be constant and differentiation of a constant is 0. एंड इसका बस अकेला यही डिफरेंशिएशन है डो वी बाई डो एक्स में इसका -5 आ गया. डो वी बाई डो वाई कितना हुआ? -5x will become 0 because it's a constant we are taking. This is also constant, we are not differentiating it. तो इसका कितना हुआ? बस 3y का डिफरेंशिएशन है, डो 3y बाई डो वाई. बाकी सब डो -5x बाई डो वाई विल बी इक्वल टू 0 बिकॉज ये कांस्टेंट है, पार्शियल डिफरेंशिएशन. अंडरस्टूड? बाकी सबको कांस्टेंट ले लो और कुछ नहीं. एंड डौ रूट 15z बस यही बचा है ना इसका, रूट 15 हो गया. तो इसके साथ फील्ड कितना आएगा? इन तीनों को मिला दो तो फील्ड क्या आएगा? माइनस ऑफ -5 विच इज +5 आई कैप. क्लास टाइमिंग is at 8 today and tomorrow, but I'm planning once we are done with this topic I'm going to change it to a little early because to मतलब बहुत लेट हो रहा है. There are a lot of classes which are happening at this time, so I was planning to make it around 4 o'clock. So any suggestions you have, just feel free to drop in, guys. Whenever you want the class, I'm going to change my timetable to around 4 or 5 in the evening. So once that happens, it will stay like that. All right. So abhi 8 hai. Today you have it at 8 and tomorrow also it will be at 8 o'clock. We are still in the transition phase right now. All right. So field is +5 I cap. Field in this direction will be +5 and in y direction it is minus of this, right? So you'll get -3 j cap and minus root 15 k cap. बस जो पॉजिटिव है वो नेगेटिव है, जो नेगेटिव है वो पॉजिटिव है. दिस इज द फील्ड. Yeah, 7:30. Yeah, 7:30 is same as 8 no man, and there are so many classes which are happening at that same particular time, and so if you want to share it everywhere it is better to do it early. 4 o'clock सोच रहा हूँ मैं. जनरली तभी क्लासेस खत्म होते हैं. You can come home and relax and just chill and watch the live video. So getting it? So field is minus is +5 I cap minus 3 j cap minus root 15. Now what is the magnitude of this field? Is root over 5 square plus 3 square plus root 15 whole square. Add kar do. 5 square is 25, 9, 15. 25 plus 15 is 40 and 49 which is nothing but 7. So electric field is 7 Newton per meter per coulomb. Got it, guys? So this is a simple problem. Now this is a very important topic, man. This topic is like this is where you can just change it. It's going to be very simple, but the way charges distribution happens, it will make the problems much more wonderful to solve. Okay. we'll do lot of problems on this eventually. But first इसका distribution of charges के बारे में थोड़ा सोच लेंगे, ठीक है? When two conducting hollow spherical shells of radius r1 and r2 have charges q1 and q2, का charge q1 is का charge q2, r1 r2, and separated by large distance, they are separated by enough large distance and joined by conducting wire. Like we discussed, what when conducting wire is there, charges are free to flow through both of them, free to flow through both the places, from here to here or here to here. Final charges are q1 and q2 respectively. The potential in both shells become equal after joining. So what do we say? The potential due to this sphere will be same as potential due to this sphere. अब sphere का potential कितना होगा? इसका q1 by, we discussed now, on the surface will be q by 4 pi epsilon naught r. If you observe, this surface and this surface are now equipotential surfaces. Equipotential surfaces, right? Both the points, which means potential here and potential here are same. इसका पोटेंशियल कितना होगा सरफेस पे? q1 by 4 पे एप्सिलॉन r1, और इसका q2 by विल जस्ट कॉल इट k, सिंपल हो जाएगा ना, k q1 by r1 है, इसका k q2 by r2, potential of rod of one, potential of two, they are separated by very large distance ना, तो इसके कारण यहाँ पे जो potential है, ये distance बहुत बड़ा है, तो compared to r1 is much less than d, which implies the potential due to others charge will be zero, will be neglected, approximately zero, will neglect it compared to this. This is so big that the other one will, how much will it be? K q2 by d होगा, इसका भी plus k q1 by d होगा. Okay, but this d is much smaller, much larger compared to r1, so we'll neglect this. This is approximately neglect. Getting it? Compared to this, मतलब 1 lakh 2, मतलब एक बंदा का rank 1 lakh 2 है, he won't say the 2, he'll just say 1 lakh. Same thing these both guys are doing. Potential they'll say kq1 by r1, we won't say kq2 by d. Okay, उस type का. Got it? So that is the main concept. U1 should be equal to U2 because they are connected by a wire. So directly first logic we'll get is Q1 by R1 will be equal to Q2 by R. That's it. एकदम simple सी logic है. This is the main logic you will apply in a lot of questions, which will make the questions interesting. Okay, the questions will become very interesting because once you connect two spheres, no, the whole equation will become very wonderful. There will be a lot of equations you have to solve, not formulas to remember. That is what I want you guys to do. You have to solve equations, not remember formulas. Okay. So next, charge. Now, what can you say about charge? Charge is density into, now this is a aerial charge. No, so now we write it in it. Now we'll look a little into the charges. How will the charges react? Charge density we'll see in this form. Will be sigma. Let's take. So Q1 can be written as what? Sigma 1 into R1 square pi into 4 pi r1 square. Okay, just write out. And q2 will be sigma 2 times 4 pi r2 square. तो इन दोनों को इक्वेट कर दिया, सेम इक्वेशन यहाँ पे डाल दिए, तो यू विल गेट सिग्मा 1 into 4 pi r1 square by r1 is equal to sigma 2 into 4 pi r2 square by r2. तो इससे सीधा क्या आ जाएगा रिलेशन? एक सिग्मा 1 r1 is equal to sigma 2 r2. लो, एक और रिलेशन भी आ गया. So using both of these, we'll just write a little inference. What is the inference we got? Q1 by Q2 will be equal to R1 by R2. The ratio of charges will be this, and ratio of charge densities will be equal to ulta of this. So इस टाइप का कुछ एक interaction you can understand कि charge densities will be proportional to inversely proportional to radius, but charges will be proportional to radius because the surface is proportional to r square, surface area. So getting it? So this is the concept, guys. I want you guys to note this down. Pause this and note this down. All right. Okay. Pause करना मतलब चले जाना नहीं है. Unpause it now and we'll continue. So we'll just look into a few problems on this also. Two conducting spherical shells are joined by a conducting wire and cut off after some time when the charge stops flowing. Find out the charge on each sphere. Ah, wonderful. तो एक का चार्ज प्लस क्यू है, एक का चार्ज माइनस टू क्यू है. So initially there is one thing you have to understand which we wrote here also. Okay, we didn't write this. But you understand initially the total charge, conservation of charge, which means finally let's take the charge here is q1 and charge outside is q2. At R2R the charge is q2, at R the charge is q1. All right. So one thing we know, q1 by R will be equal to q2 by 2R. This is what we discussed in the previous question. And one more thing, conservation of charge. You have to use the concept of conservation of charge. तो conservation of charge से क्या हो रहा है यहाँ पे? We know the total charge is q1 plus q2 finally. And initially, what is the total charge? Total charge should remain same. No, there is no extra charge coming from anywhere. It should be equal to q minus 3. Directly we will get q1 plus q2 is equal to minus 2q. ये दूसरा इक्वेशन हो गया. पहला इक्वेशन ये था, ये कैंसिल किया तो इसमें क्या आएगा? q1 is equal to q2 by 2. This is first equation, and q1 plus q2 is equal to minus q2. Substitute the whole thing. We'll directly get 3q2 by 2 is equal to minus 2q. q2 is minus 4q by 3 and q1 is half of it, minus 2q. तो एकदम यहाँ पे एक लॉजिक समझ में आ गया. द रेशियो ऑफ रेडियसेस विल बी इक्वल टू रेशियो ऑफ चार्जेस व्हेन दे बोथ आर कनेक्टेड टुगेदर. मस्त है. अंडरस्टूड. So note this down. Got it? So pause it and then copy it and then unpause it now. Over. Let's go. Okay, this is another cool problem. Charge distribution of charge on a conducting sphere. Find the charge on the inner sphere when the inner sphere is grounded to zero potential. So this is very interesting question. So this is where I enjoy in this. So you have to understand carefully. The potential on this surface is zero. On the outer surface, this is non-zero. We know how much the potential there is. We already remember we solved the problem today in the beginning. So we know the potential on the outer surface, but inner surface, the potential at this point or the entire surface is zero. So चलते हैं, let's solve it. So due to the outer sphere, due to sphere B. So first let's take this. यहाँ पे outer sphere में charge plus q है, तो यहाँ पे small q डाल देंगे. Let's say because of grounding there is small q charge which is coming from the ground to there. Got it? तो यहाँ पे q charge डाल दिए. तो अब क्या करेंगे? The outer potential due to outer sphere plus potential due to inner sphere will be total potential at A. आउटर स्फीयर भी है, उसका पोटेंशियल भी आएगा और इनर पोटेंशियल भी आएगा. तो दोनों मिला के पोटेंशियल एट होगा विच इज इक्वल टू जीरो. व्हाट इज द वी ड्यू टू आउटर शेल? वी नो इट इज once it reaches the shell, everywhere inside this constant potential and it is equal to kq by r. Remember, so in this particular case it is equal to k into q by p. Got it? So that is the simple formula you can remember. Potential is kq by r. I got the outer potential as kq by b, and potential due to inner surface, which is the inner sphere. It will behave like a point. It will behave like a point object. On the surface, it will just be normal, like a point charge. How much will it be? K into q by a. समझ में आया? This will be kq by a. That will be kq by b. So what is the total potential now? It is kq by b plus aq by a. This whole thing is equal to 0. From this directly we will get q by a is equal to minus q by b, or q is equal to minus q into a by. बस हो गई बात. Same logic, like if you link these both, they both will have same potential. If you link that to 0, this will have negative of that potential, exactly negative of the potential of the sphere. सिंपल नो. यहाँ तक इन्फिनिटी से आए, यहाँ पे पोटेंशियल है. यहाँ से यहाँ तक जीरो हो जाना चाहिए ना, तो यहाँ पे माइनस भी हो जाना है. अंडरस्टैंडिंग द पॉइंट? Just a scalar, you have to add one positive to a negative. So the potential due to this sphere should be minus v. Outer sphere is kq by a. Inner sphere is minus kq by a, which is equal to kq by b. हो गई बात. kq by minus kq by b, which is equal to kq by b. Clear? यू अंडरस्टूड हाउ इट वर्क्स? यहाँ तक पोटेंशियल V था और यहाँ पे माइनस V ऐड हुआ, विच मीन्स पोटेंशियल ड्यू टू दिस पेयर शुड बी माइनस V, अगर जो भी प्लस V आया. That is how you analyze it, or you can directly apply sum of all. From infinity you are coming across, when you're coming from infinity to inside, everything outside will affect the change in charge potential. वही है. क्लियर ना सब लोगों को? पक्का? अगर कुछ if you are able to understand well, hit the like button, hit the share button, subscribe to everything in social media which is possible. We are going to make great videos, guys. पूरा analytical होगा. There will be very few little maths. I'll want to make it either maths intensive. With maths is simple, okay? I don't want to make complex math into this. That's what my target is. I want to make maths the language easy. So सबको share कर देना. Yes. Next, distribution of charge on conducting spheres. There's one more question. How much charge will flow into the earth if the inner sphere is ground? Now this is the same logic we'll apply. Within 1 second we will solve this problem. Alright. मस्त trick एक बता दूंगा मैं. Two conducting spheres. Initially there is charge q here and charge 3q here. That is what is given. Alright. Now how much charge will flow into the earth if shell is grounded? ये शेल अगर ग्राउंडेड हो गया तो कितना चार्ज आएगा? हाउ कितना चार्ज विल गेट इनटू द आउटसाइड? वन थिंग वी जस्ट डिस्कस्ड हियर, द फाइनल चार्ज हियर, ये माइनस क्यू है यार, सॉरी दिस इज माइनस क्यू. क्वेश्चन में थोड़ा यहाँ पे माइनस क्यू चार्ज है और यहाँ पे प्लस 3q है. So now I will give you this question. I want you guys to solve it. All right, using the previous questions logic, same logic, I want you guys to solve this question. And your timer थोड़ा आज मैं अलग पेज में टाइमर किया using the laptop. Timer starts now. 1 minute स्टार्ट हुआ, उसमें सेकेंड्स 55 seconds. बताओ तुम लोग, हाउ मच चार्ज विल फ्लो? So I want you guys to share this everywhere because ये perspective जो है I want you guys to understand. मतलब पूरा एक ही है. Everything has only single logic which is potential energy ऊपर होगा मतलब external work positive है. External work positive है मतलब field का work negative है. And potential is work done by unit charge. सब मतलब एक ही फॉर्मूला से इतने बड़े आते हैं सब. तो no need to remember the whole thing. I want you guys to just do it a little slow. And I want you guys to share it everywhere. Like this video first of all and share it everywhere because that is how this perspective can spread. I want to spread this to Unacademy. Na, 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 na. Yes, we got an answer, but kq by 4r square. What is that answer, man? I asked how much charge will flow. All right, take that's it. Time up, guys. So it is in terms of charge. Okay, you got some. You got a force there. I think which is actually correct. The force you got is right. The field at this point is correct. Okay, you got the field at this point. Great job. Yes, Q by 2 Hadya Ahuja got is right. Exactly on time. You guys did a great job. You on time. Sim 24 even found out the field at this point. The potential zero है तो field कितना है? याद रख लेना potential zero का मतलब ये नहीं होगा, ठीक है? Field भी हो सकता है. So it is just like potential, like how you solve gravity. I want you guys to understand the concept here. कि potential zero है मतलब ऐसा नहीं है कि field zero है. Like you have gravity here. Suppose I'm defining potential energy zero here. It does not mean here gravity does not exist. Same way, potential zero का मतलब field नहीं है. और Sim 24 gave the field answer and Adya got the question right. Yes. So let's solve this. Just like we discussed before, the charge on here, final charge be Q. So we can say directly minus Q by R should be equal to plus 3Q by 2R from the previous logic only. Q by A is equal to minus Q by B for zero potential. तो इससे सीधा क्या आ गया माइनस थ्री क्यू बाई टू क्यू इज इक्वल टू माइनस क्यू इज इक्वल टू थ्री क्यू बाई तो क्यू ही ले लेते हैं ना क्या है इसमें क्यू बाई आर इज इक्वल टू थ्री क्यू बाई टू सो वी डायरेक्टली गॉट क्यू इज थ्री क्यू बाई टू सॉरी तो माइनस थ्री क्यू बाई टू हो गया इनिशियल चार्ज देख फिर से बता दूँ we got this formula q is equal to minus qa by b. I will use this only. We can solve it separately or we'll just use this formula. Q final will be equal to minus 3q into a which is r by 2r. So directly we'll get minus 3q by 2. यहाँ पोटेंशियल भी खींच लो यहाँ पे पोटेंशियल कितना है 3q by 2r into k यहाँ का q into k q by r दोनों को ऐड कर दो इक्वल जीरो कर दो हो गया 3q k by 2r plus kq by r is equal to 0 from this we'll get kq q is equal to minus 3q by 2 same thing we can solve it in many ways we get the same answer which is pretty straightforward so अब initial charge minus q है and finally minus 3q to 3q by 2 है मतलब कितना चार्ज हाउ मच विल फ्लो इनटू द अर्थ तो यहाँ पे माइनस क्यू है तो यहाँ से एक्स्ट्रा अगर चार्ज फ्लो हो गया तो और नेगेटिव होगा ना इफ इट्स गोइंग टू माइनस थ्री क्यू व्हाट इज द चेंज इन चार्ज द चेंज इन चार्ज इज इक्वल टू फाइनल चार्ज माइनस initial charge which is minus 3q by 2 minus of minus q so the change in charge is minus q by 2 this much charge has changed it lost so it lost q by 2 charge how much charge will flow the answer is plus q by 2 no प्लस एंड माइनस का ही मेन फर्क है तो देखो यहाँ पे इनिशियली इतना चार्ज है माइनस क्यू चार्ज है तो ले लो बाद में और कम हुआ minus 3q by 2 हुआ which means it lost this much charge means this much charge flew outside q by 2 charge went outside समझ में आ रहा है आ गया तो how much charge will flow into the earth the answer is plus q by 2 तो ये सटल डिफरेंस तुम लोगों को समझना है इसके लिए एनालिटिकल थिंकिंग ही बोल रहा हूँ मैं दैट इज व्हाई आई एम पुशिंग एवरीथिंग इन एन एनालिटिकल वे बिकॉज once you don't have any formula to look forward to you can analyze it and see initially minus q चार्ज था फाइनली और घट रहा है मान लो इनिशियली प्लस क्यू चार्ज है प्लस क्यू से क्यू प्लस क्यू बाई टू हो गया हाउ मच चार्ज फेल आउटसाइड क्यू बाई टू चार्ज वेंट आउटसाइड सेम वे माइनस क्यू से और घटा तो माइनस थ्री क्यू बाई टू विच मीन्स प्लस क्यू बाई टू चार्ज फेल आउटसाइड राइट दिस इज वाई आई एम टेलिंग मतलब फॉर्मूला अप्रोच से ये इट विल बिकम टफ टू अंडरस्टैंड ठीक है कभी कभी प्लस माइनस में काफी कंफ्यूजन हो जाता है कभी कभी मतलब फॉर्मूला याद रखने में इश्यू हो जाता है दैट्स व्हाट आई वांट एवरीथिंग टू बी एनालिटिकल थोड़ा फॉर्मूलास याद रखना है एंड देन सॉल्व एवरीथिंग बाय लॉजिक लाइक वी डिस्कस टुडे डाइपोल का भी कैसे डिस्कस सेम वे जस्ट अंडरस्टैंड एवरीथिंग इन सिंपल पर्सपेक्टिव इलेक्ट्रिक फील्ड के डायरेक्शन में अगर मतलब इलेक्ट्रिक फील्ड कुछ पॉजिटिव वर्क कर रहा है तो पोटेंशियल एनर्जी डिक्रीज हो जाएगा उस टाइप का लॉजिक्स याद रखना दैट्स ऑल so charge flow here is q by 2 plus q by 2 got it great one so now for the next question distribution of charge on a conducting spheres find the so यहाँ पे q है यहाँ पे minus 2q है यहाँ पे plus so this is little more complex than the previous question because there is an extra charge extra radius in the middle कोई नहीं कर देंगे after joining the innermost shell and the outermost shell by conducting wire which means now the potential here and here will be same guys this is a very nice classic question एकदम classic question here okay. this is where it gets very analytical so इसको मैं solve कर दूंगा so just relax if you are able to solve it faster than me please type the answer there but I'm not waiting because I'll keep explaining on the go all right those who want to solve it you can start right away चलो solve करो तो मैं जनरली आई ऑलवेज लाइक टू सॉल्व इक्वेशंस इन टू वेरिएबल्स ठीक है ज़्यादा एक ही वेरिएबल में सॉल्व करने में दिक्कत होगी तो मेन थिंग दैट इज व्हाट आई बिलीव इफ यू वांट टू डेवलप आईक्यू इट इज इन टू वेरिएबल्स नॉट इन सिंगल वेरिएबल तो इसलिए मैं इसका चार्ज q1 मानता हूँ इसका चार्ज q2 what do we know the sum of charges remain same because they are not grounded or anything they are just connected to each other which means I can say q1 plus Q2 will be equal to 6Q. This is the first equation I get. All right, clear, loud and clear, no doubts whatsoever. Good. Q1 plus Q2 is equal to 6Q. And next, potential at this point at A and at B. Potential at A will be equal to potential at B. यहाँ पे बहुत ज़्यादा कॉन्सेप्ट्स का एप्लीकेशन होता है, ठीक है. Potential at B, which means every charge is inside. So going from infinity to a particular point like this, so every charge will behave like point charge because तुम किसी शेल के अंदर घुसाए नहीं, तो everything will behave like a point charge still there. So directly I will say potential at B will be equal to K into Q1 plus Q2 plus Q3 by total distance कितना था 3R. सीधी से बात, डायरेक्ट, कोई डाउट नहीं है इसमें. एवरी चार्ज विल बिहेव लाइक अ पॉइंट चार्ज एट बी. So this is the inference I want you guys to understand. At B, every charge sphere is a point particle because everything is coming from infinity to that point only is a point particle. तो सीधा सबका टोटल चार्ज करके पोटेंशियल निकाल दिया, हो गई बात. तो हाउ मच इज दिस वैल्यू नाउ? This will be equal to K into Q1 plus Q3 is 6Q and minus 2Q. तो कितना होगा? K into 3 4Q by. So this is one thing we found out, the potential of the outer surface. Now about the inner surface. Inner surface में तो ऊपर से शेल के अंदर से घुस रहे हो. You are getting into the shells of 3 and 2. So potential at A will be equal to आउटर मोस्ट शेल का जो आउटर है बाहर था वही कांस्टेंट रह जाएगा. So it will be K into Q2 by 3R, right? Because once it gets to the 3R surface, the outer shell will have constant potential, which is equal to K into Q2 by 3R plus K into minus 2Q by 2R भी ये सेकेंड शेल का है, ठीक है. और इनर शेल का भी रेडियस R है अब, तो K into Q1 by R. समझ में आ गई बात? Very clear. This is the final potential at A. So now we have to equate both of them. Just let's take one more. अब देखते हैं. Field outside, field at B will be 4KQ by 3R. And field at A is कितना? KQ2 by 3R minus KQ by R. ये 2KQ by 2R हो गया ना, तो minus KQ by R plus KQ1 by. दोनों को इक्वेट करो, इन दोनों को इक्वेट करो, इक्वेट both of them and you will get the answer right away. This is 1KQ by R. If I send it to the other side, it will become addition, right? So I'll directly write 7KQ by 3R because I'm adding this, I'm sending this to this side and equating both of them. So what will I get? 7KQ by 3R will be equal to K into Q2 by 3R plus K into Q1 by R. So just the whole thing I'll just cancel out K's, multiply of R's and multiply with 3. Multiply with 3R by K कर दिया. What will I get? 7Q is equal to Q2 plus 3Q1. And what is the first equation we got? Q1 plus Q2 is equal to 6Q. बस हो गई बात. इसको just subtract कर दो, you will get off one simple equation here. Q2 Q2 is gone, you will get Q is equal to 2Q1, which implies Q1 is equal to Q by 2, and similarly Q2 will now be equal to 5Q by 2. 5Q by 2 नहीं, कितना है? 11Q by 2. बस हो गई. Simple distribution of charge. ठीक है, got it. Straight forward है सब कुछ. So this is the solution, guys. A great job. मतलब मस्त. It's been very nice seeing the audience. ऐसे तो दिस इज अभी सॉल्व. एकदम सिंपल कैलकुलेशन से, कोई टेंशन नहीं है, आराम से करो. 2 इक्वेशंस में सॉल्व करने से हमेशा यू विल नेवर गेट इट द इक्वेशन कॉम्प्लिकेटेड, ठीक है. सिंगल इक्वेशन में अगर इफ यू आर राइटिंग एवरीथिंग, लाइक यू कैन आल्सो स्टार्ट ऑफ बाय सेइंग दिस इज x एंड दैट इज 6 - x, तो थोड़ा बड़ा हो सकता है, इसमें स्ट्रेट फॉरवर्ड आ जाएगा. This is one thing I find very it is easier to solve in two variables than in single variable. हाँ, ये एक बहुत सिंपल कॉन्सेप्ट है. डिस्ट्रीब्यूशन ऑफ चार्ज ऑन कंडक्टिंग प्लेट्स व्हेन टू कंडक्टिंग प्लेट्स आर कनेक्टेड. तो लॉन्ग इनफाइनाइट कंडक्टिंग प्लेट्स अगर ले लिए तो यहाँ पे फील्ड यूनिफॉर्म होगा. दे आर वेरी फार अवे, ऐसे सोच लिया. तो व्हेन दीज बोथ आर कनेक्टेड टुगेदर, what happens is, because they have same field, they'll have same field. Eventually if they want to reach same potential, we know charge density here is sigma by 2 epsilon naught epsilon naught. इसका भी sigma 1 sigma 2 ले लिया. When they're connected by same potential, eventually what will happen is that the field, they should have same potential, which means eventually they should have same fields. When particles are coming from infinity, they should have same fields, which implies they should have same charge densities. Sigma 1 final should be equal to sigma 2 final, which means sigma final will be equal to total charge, which is sigma 1a plus sigma 2a by total area 2a. Sigma 1 plus sigma 2 by 2. Charge will get equally distributed when there are two infinite plates. Okay, we don't have a problem on this because this we will do this as we go. Okay, so final sigma will be sigma 1 plus sigma 2 by 2. Now we will do a couple of multiple concept problems, guys. This is the final part of it. Tomorrow we will discuss a very small topic, and then we can solve problems. We will have a 2 days of exclusive problems. We will just keep solving every problem we find on the way. We'll do a few IIT problems also. Stay tuned for a lot of uh, problems and different approaches. So yes, this is one more question. This question we should be discussing about. A proton moves. This is very analytical. Okay, a proton moves with the speed of a proton moves with the speed of 7.45 into 10 to the power 5 meters per second. What is the mass of a proton? Generally, we take it as 1.67 into 10 to the power minus 28 kg, right? 8 only. 28 or 27? Fine, just let me know. Yeah, minus 27 है. See, beauty of internet, man. Everywhere you know. This is the beauty, yeah. That is why I'm telling you. The formulas का time, analysis का time है. That is how the world is going into right now. Understanding and analyzing tech is the next big thing. You need to keep constantly analyzing stuff, right? तो speed कितना है, velocity इतना है, तो free proton originally at rest, directly at a free proton which is originally at rest. Find the distance of closest between the two protons. Wow, this ये must question है, ठीक है? तो इसको मैं ये सब I always tell you, right? Whenever we tackle these kind of questions, the best way to approach it is through variables, right? इसका मास m ले लो, चार्ज q ले लो, इसका मास m ले लो, चार्ज q ले लो. All right. Initially, it is moving with some potential. It is moving with kinetic energy. Finally, when they come closer, they will have one potential energy, and at that time, the speeds will also vary. इसका velocity v ले लो फिर initially. तो अब इसको solve करने लग जाते हैं. One thing we know that force is equivalent and opposite on both of them. So net force on the system will be how much? 0. Which means what can we conserve? We can conserve momentum, guys. This is one very important thing you have to understand. When you have these kind of gravity questions, especially gravity and electrostatics questions, you have to understand that momentum will be conserved. Forces are equal and opposite in most of cases. So initially m into v naught मान लो should be equal to finally. So one more thing, when they are at the closest approach, both of them will try to move together. That is one. So this will start pushing this. ये आता जाएगा, the moment it comes closer, this will start pushing this forward, and this will start pushing this forward, and eventually at some point both of them will have same velocities. That is when they get closest. No one after that, this will start going faster and this will start coming slower. Getting the point? तो logically क्या होगा, initially ये एकदम fast आ रहा है, इसको invisible force है, तो ये भी घूमना start करेगा. At one particular point both will have same speed, and then this will start going forward, and this will behave like an elastic collision. Eventually the whole process, यार इसमें है, ये आएगा सट, boom, simple. Okay, so eventually they both will have they'll undergo elastic collision type movement where finally this particle will be at rest, this particle will be moving with me. So at the closest approach, they both will be moving together. After that, this will move faster, this will move slower. Eventually हो जाएगा. So it will be equal to 2 times m into v final, and both the v finals will be same. That is why I wrote 2m into v final. So directly v final is v naught by 2. So bus हो गई बात. We got the final velocities. We know initial velocity. We have to only link with potential energy. So here we'll use conservation of mechanical energy because kinetic energy initially will get converted into potential energy and finally it will get back converted into kinetic energy. Change in mechanical energy is zero, which means initial kinetic energy will be equal to final potential energy plus kinetic energy final at closest approach. This is at closest approach. Clear everyone? Oh sir. Yeah, correct. Yes, thank you. V final is V naught by 2. तो ये समझ में आ गया ना सबको? Kinetic energy initial will be kinetic potential energy final plus kinetic energy final. Initial kinetic energy कितना है? Half into m into v naught square will be equal to half into 2m into v final कितना था यहाँ पे v naught by 2, तो v naught by 2 whole square plus what is potential energy final. अब generally two particles का potential energy कितना है? k into q1 q2 by r square, right? q1 q2 by r. तो यहाँ पे सीधा सीधा कितना हो जाएगा? k q square by r हो गया. तो इसको लिख दोगे यहाँ पे प्लस हाफ एम वी स्क्वायर विल बी इक्वल टू यहाँ पे क्या है? ये दोनों कैंसिल हो गए तो ये कितना हो गया? 1/4 एम वी नॉट स्क्वायर हो गया प्लस के क्यू स्क्वायर बाई आर. इक्वेट कर दो. 1/4 एम वी नॉट स्क्वायर इज इक्वल टू के क्यू स्क्वायर बाई आर. सीधा इससे आ जाएगा आर विल बी इक्वल टू 4 के क्यू स्क्वायर बाई एम वी. Great solution, guys. This is how simple it is. Now इसको we have to start solving in terms of values. इसमें लगा देंगे हम. Let's start putting values here. Let this. Okay. ये बगल वाला equation. These are the two equations we used, right, to solve this. So we just put the whole equation. We got the value here. What is the value of r here? 4 into 9 into 10 to the power 9 into q square. ये कितना हुआ? 2.56 into 10 to the power minus 38 by mass 1.67 into 10 to the power minus 27 into v naught square, which is 7.5 square into 10 power 10. आपको कैलकुलेट करो, बहुत लंबा. ये 10 पावर माइनस 27, ये यहाँ पे माइनस 18 हो गया और ये 10 और 9 कैंसिल होकर यहाँ पे एक 10 बच गया. ठीक है, तो इसमें क्या हो जाएगा? ये 10 पावर माइनस 27, ये 10 पावर माइनस 27 और माइनस 38 से ये 10 हो गया. ठीक है, और ये 11 हुआ और यहाँ पे एक 10 बच गया, तो ये 10 पावर माइनस 12 भी हो गया. द होल थिंग विल हैव 10 पावर माइनस 12 and 4 into 9 into 2.56 by 1.67 into 7.5 whole square. हो गया, इसको कैलकुलेट कर दो. हो गया. दिस इज 56.25. 7.5 square is 56, so I'll write it as 56. तो ये 56 14 टाइम्स कर दिए. ये 56 14 टाइम्स कर दिए. 1.67 into 14 कितना है? इट विल कम आउट टू बी 2.3, समवेयर अराउंड 2.3. भाई ऊपर 23 हो गया. वाह. तो इसका आंसर 10 पावर माइनस 11 मीटर्स अप्रॉक्सीमेटली. ठीक है, तो दिस इज हाउ यू कैलकुलेटेड, सिंपलर कैलकुलेशन. बट मतलब ऑप्शंस देख के कर सकते हैं इस क्वेश्चन. आई डेंट गिव यू ऑप्शंस बिकॉज आई वांट टू सॉल्व इट इन फ्रंट ऑफ यू. वी विल हैव ऑप्शंस टाइप क्विज टाइप सिचुएशन टुमारो. ऑलराइट, so bring everyone in. We will have a quiz type situation in the class. I will see we can also have a quiz tomorrow. So stay tuned. This is how we solve this problem. Getting it? तो एनर्जी को इक्वेट किया. इनिशियल काइनेटिक एनर्जी विल बी इक्वल टू, बिकॉज इनिशियली पोटेंशियल एनर्जी जीरो, नो, क्योंकि दोनों इनफाइनाइट डिस्टेंस पे है. इनिशियल पोटेंशियल एनर्जी जीरो, फाइनल पोटेंशियल एनर्जी इज व्हेन दे आर क्लोजेस्ट टू ईच अदर and this is the closest value. Clear? So yes, this is able to pause this and note this down. Yeah, today we don't have quiz, man. We'll have it tomorrow. Okay, we have a quiz tomorrow. Great response in the quiz, by the way. I'm telling you, every one of you should come to the quiz, the daily quiz show. Daily quiz show. I'm going to make it alternate day quiz show, basically. That's what I'm planning. Daily quiz show where you'll have quiz from all topics, matlab, all topics in physics, and sometimes one odd day I want to give you some IQ tests also, which happened the other day. I'll give you IQ quizzes and all kinds of quizzes which help you tackle JEE exam. I want you guys to crack JEE exam by using a test every day. A quiz a day makes you ready for IIT-JEE any day. Okay, we'll be having that, guys, for sure. So this is a solution now for the next one. Pause karo, unpause karo. Another very similar question. A very mass 80 grams having a charge q is held at a height 9 meters vertically above the center of a fixed conducting sphere of radius 1 meter. Carrying an equal charge q, दोनों का charge q है. When released with the ball, if it falls under until it's repelled back just before it comes in contact with the sphere as shown. यहाँ से गिर रहा है वो. Just before it comes here, it'll come in contact. Just before it comes to contact, it will stop. So he's asking us to find the value of q. तो इसमें क्या करेंगे? इसमें भी सिंपल है. इसमें kinetic energy initially zero, it's at rest initially, and just even after it falls here also it is at rest. No. So which means kinetic energy is not changing everywhere. What is changing? The potential energy is changing. Gravitational potential energy is all right. So initially gravitational potential energy ज़्यादा था और electrostatic potential energy कम था. Initially, potential due to gravity plus potential due to electrostatics will be equal to UG final plus UE final. बस इस टाइप का लॉजिक है इसमें. Same thing mechanical energy में last time you equated kinetic energies and potential energy, no? This time we are equating both kinds of potential energy. Yes? It is that straightforward. It's no confusion. Great combination. तो इनिशियल पोटेंशियल ड्यू टू ग्रेविटी कितना है? m इंटू जी इंटू 9 h1. मैं सब वेरिएबल्स में लिख देता हूँ. जस्ट नो, लेट्स m इंटू जी इंटू 9 ले लो. mg h है ना पोटेंशियल एनर्जी. ug फाइनल विल बी इक्वल टू m इंटू जी इंटू 1. All right, and same way potential electrostatic potential energy initial will be equal to k into q square by the distance between them is 10 meters. No, this is 9 plus 1 10 square, 10. And finally UE final will be equal to kq square by what is the final separation from here to here? This is almost 1 meter, no? So I'll just write 1. Equate both of them, हो गई बात. 9 mg plus kq square by 10 is equal to mg plus kq square. Then the whole thing as 8 mg is equal to 9 kq square by 10. So q will be equal to root 80 mg by 9k. Okay, but that's it. So the moment you solve this kind of variables, that is why I tell you guys to solve it in variables, because if you get in variables, you know that you are doing it right. You don't have any calculation mistakes whatsoever. So last me you substitute, you'll get the best possible answer. 80 into mass of it is 0.80 into 10 power minus 3 in grams. The gravity is 10 by 9 into 10 to the power 9. Wow. होगी बात. वंडरफुल. 80 दो बार आया, 9 दो बार आया, तो सीधा उसको बाहर फेंक दूंगा. 80 by 9 कर दिया इंटू रूट ओवर 10 power minus 3 into 10, 10 power minus 2 by 11, 10 power 9 over. So the answer is 80 by 9 into under root of 10 to the power minus 11. तो कैलकुलेट कर दो. 80 by 9 into 10 to the power minus 11 मतलब ये 10 to the power minus 5 आ गया इंटू 1 by 10 to the power minus 6 इंटू रूट 10. तो ये 10 power minus 12 प्लस रूट 10 कर दिया, तो ये इंटू रूट 10 मतलब 3.14 हो गया. So now you start solving. This is 8.88. So if you add the whole thing, you will get 8.88. This thing is 27 10 to the power minus. So this is about it, guys. Are you able to solve this? So easy है ना, कोई टेंशन नहीं है. कैलकुलेशन में कोई टेंशन मत लो. The only thing I want you guys to understand is if you get this concept right, which this, if you get this concept, this is what is main thing. mechanical energy initial is equal to mechanical energy final. Yes, so that is about it. So that is the end of the class today, guys. We will continue with more problems tomorrow and day after tomorrow, and then we will go into current electricity. All right, we will do a lot of problems tomorrow, and we'll also discuss some multiple concept problems based on field and surface tension. Any such problems. All right. So crack IIT-JEE with India's largest platform, which is Unacademy. And before you go further, I want you guys to share it everywhere possible because I want this to go viral. Like everyone should understand certain topics which are being explained. And use the code NSS1 when you take the plus subscription. Hit the bell icon for more updates and keep watching into this channel. All right. So bye Sim24, bye Adya. Great job, guys. Ramesh and all, great job. Thanks for being here. It was a wonderful experience today, and see you again tomorrow. Okay, tomorrow at same time at 8 o'clock, we will be here. Yeah, at this place. I know we are having quizzes every day. Today we are taking a break because too many quizzes. Okay, so I'm just taking a break today. We will have another quiz tomorrow, and we'll have class also. All right. So see you tomorrow, guys. Until tomorrow, and stay tuned here tomorrow. Until then, adios, amigos.